Hello, wonderful students. This is Mr. Manson, and today we're going to do two things. We're going to do a new lesson on what is referred to as the logarithmic exponential forms, and I'm going to offer some assistance on our next assignment, assignment number 7. So, what's important about logarithmic functions is they help us measure earthquakes, pH in the blood. So today what we're going to look at is first various things in exponential forms that you're familiar with. So for example, if I do 2 to the third power, you know that 2 is the base, 3 is the exponent, and the exponent tells the base how many times to multiply against itself. You know that 2 times 2 times 2 is 8. So we can do this with various numbers. If I say 4 to the 2, you know it's 16. If I say 5 to the 2, you know it's 25. If I say something like 6 to the third, you know it's 216, and so on. So all of these are written in the form of b to the x equals y, where b is the base, that's the big number that holds up the exponent x, and it always equals some number. So all of these are considered exponential form. So all of these in exponential form can also be rewritten in logarithmic form. So what is this thing, logarithmic form? Well, we're going to shorten this to be the word logarithm. And we can even shorten that further to be the word log. And today we're going to look at a logarithm as a log. So we're going to start off by writing what the logarithmic form is. We write the word log. And the next thing we're going to write is this little letter b. And b is going to go right after the g, just like that. It's a little b. And then next to the b, we're going to put y, and the y is going to be as big as the g, o, and l. And we're going to set that equal to x. And that, ladies and gentlemen, is logarithmic form. So what we do here is this. All of these numbers here are the b's. These are the bases of all these in exponential form. All of these little numbers are the exponent, and it equals the number there. If you take what each number represents for the letter and then substitute it for the letters here, you've rewritten it in logarithmic form. So for example, 2 to the 3 equals 8, 2 is the b, 3 is the x, and the 8 is the y. So I write that as log. This is read as log base b, of y equals x. Try to squeeze that all in there. So this is read as log base b of y equals x. So for this example, 2 to the 3 equals 8 would be written as log base 2 of 8 equals 3. And that's all you do. That's the answer. 4 to the 2 equals 16 would be rewritten as log. The base of the exponent is also the base of the logarithm. So it's log base 4. The of part will always be the number of what it equals. So it's like the big numbers want to come together. So 16, and it will always equal what the exponent was. It was 4 to the 2, so it would equal 2 right there. And that's how you write that one. Let's try the next one. 5 to the 2 equals 25. Well, that will be log base 5 of 25 equals 2. Just like that. Can you try this one? Go ahead, I'll give you a moment. You got it. Log base 6 of 216 is 3. All right, so that's pretty straightforward. The other thing we're going to do is to look at how we're going to go from logarithmic form back to exponential form. I think these are fun. So let's look at a few examples together. Suppose I was given the log base 2 of 8 equals 3. And this is given as logarithmic form. And the reason why is because it's written as log base b of y equals x. So remember, that is the form to be a logarithm. Now, if we want to write that to be an exponential, that's in log form, we want to write that as b to the x equals y. So we say here that the little 2 is the b, so that would be the big B, so I write that as 2. The x here is the exponent here, so that's what the logarithm equals. Since it equals 3, I'm going to replace this x here with the number 3. And that will equal the remaining letter y, which is this number right here, what you're taking the log of, which is 8. So I write the 8 here, and that's the answer. Let's try another one. Suppose I had log base 5 of 125 equals 3. So the b is the 5, the y is the 125, and the 3 is the x. So there's this other shortcut I like to use. It's called around the world. I start here at the 5, and I go across the equal sign to the 3, and then 3 goes across the equal sign again to the 125. And that's the setup. And what's cool about going from log form to exponential form is that the answer should make sense. So if I take 5 and raise it to the 3, I most definitely should get 125. And that makes a lot of sense there. How about this one? You try this one. Log base 3, let's change that 3 to an 8. Log base 8 of 64 equals 2. I'll give you a moment. How would you write that in exponential form? Well, if you said 8 to the 2 is 64, by golly, you got it. So that, ladies and gentlemen, is how you go from logarithmic form to exponential, and how we go from exponential to logarithmic. The last thing we're going to look at is assignment number 7. And let's do a couple examples together so you get a feel for this assignment. Now, as a recap, remember, exponential form to logarithmic form. All you do is just copy the colored letters to numbers there. And it said as log base b of y is equal to x. And that should say equals 2. I just put an equal sign there instead. All right, let's take a look at assignment 7. So for this one, there's 25 questions all day. And for 1 through 15, rewrite each in logarithmic form. All right, so I put the little rule in the corner in case you forget. This number 1 says 2 to the 3 equals 8. So I write that as log. The base of the exponent is the base of the logarithm. So the little number will become a 2. And these big numbers want to come together. So this would be the x over here. The 8 is the x. So I write that here as 8. It will always equal the exponent. Let's try another one, number 5. This one says 10 to the 3 equals 1,000. So if I write b to the x equals y, b is 10, the x is 3, and the y is 1,000. So it's log base b, which is 10, of y, which is 1,000, equals x, which is 3. And that's how you do that one. Let's try number 12. 5 to the 4 equals 625. I just write that as log base 5 of 625 equals 4. All right, so that's pretty much straightforward there. Number 15, I just want to see what you can do with that fraction over there. All right, 16 to 25. Let's take a look at 16. Now here we want to rewrite each in exponential form. So log base 2 of 4 equals 2. So this is like saying log base b of y equals x. So b is the 2, y is the 4, and the x is the 2. So according to that rule, I'm going to take that b, x, and y, plug them in here, and rewrite it like this. So 2 is the b, so that's 2 to the x, so the x is 2, equals 4, and that's the answer. And it should make sense. 2 to the 4 doesn't equal 2. 4 to the 2 doesn't equal 2, so 2 to the 2 must equal 4. Let's see, let's try number 19. Now there's a shortcut here. If you don't like the letter way, start with vanilla number 3, go across the equal sign, I call this around the world, and then 2 goes across the equal sign to the 9. So 3 to the 2 equals 9. And let's try one more. Let's try 23. 23 says log base 4 of 10,000 equals 10. Okay, so I start with a 4, go across the equal sign, and I discovered here that that is a misprint. When I created this assignment, the 4 and 10 should be switched around, so I will make that correction here. In fact, on your homework it will be corrected. That would be a 10 and that's a 4. My bad. And here's why it's a mistake, because when 10 gets raised to the 4, then it would equal 10,000. So I'm sorry about that, guys, my bad. All right, so the rest of them should be just fine. So keep on doing the good, wonderful work, and I will see you soon. Take care.